video, we're going to discuss about our second subtopic in the chapter 2, which is inequalities. For the subtopic inequalities, you should be able to relate the properties of inequalities, find the answer for the linear inequalities by using the algebraic method or the number line, and solve the quadratic inequalities by algebraic or graphical approach. We're also going to write the answers in the form of solution set or interval form. Starting from now, we're going to use a lot of this symbol that we have here. For example, we have greater than or less than, or if we have the underline here, it is greater and equal to or less and equal to. So let's check out the examples that we have here. For example 4, find the solution for the following linear inequalities. For the question B, 4 minus 2x less than equal to 12. In this case, we can rearrange them by using the normal method that we want to use to solve for the x. For this question, we only move the 4 to the right hand side. So we have negative 2x less than equal to 12 minus 4, which is negative 2x less than equal to 8. So if you want to solve for the x here, you need to leave out the x as the subject on the left hand side. So we need to divide by negative 2 for both sides. For the inequalities, if you multiply or divide by the negative number, the sign here will be changed. So we have here x greater and equal to negative 4 if you divide for both sides with negative 2. To find out the answer, we want to use in interval form or the solution set. Negative 4 here, you need to write the line number here with negative 4, negative 3, negative 2, and so on in ascending order. Now, if you see the sign here is greater and equal to, you need to bear in your mind it is the closed interval starting from negative 4. And then, if it is greater than, so the arrow will shift to the right. The region that we need to consider is now all the right hand side towards the positive infinity. So the answer will be from negative 4 towards positive infinity with close for the negative 4 and open for the infinity. For the example C, we have 6x less than 4 minus x less than equal to 12 plus x. We can see here that we have two signs of inequalities in a line. For this type of questions, you need to separate them so we can solve them separately. We have here 6x less than 4 minus x, and another one we have 4 minus x less than equal to 12 plus x. In the end, the answers for these two parts will be combined using the properties of n, which we want to consider the intersection part. I want to start with the left hand side. For the left hand side here, we have 6x less than 4 minus x. So you need to solve them by bringing the x to the left hand side. So we combine here 6x plus x less than 4. Now we have 7x less than 4, and now x is less than 4 over 7. This is the answer for the left hand side. Now we want to solve for the right hand side. For the right hand side, we have 4 minus x less than equal to 12 plus x. Now we want to combine the x to be on one side and all the numbers to be on another side. So we have here negative x minus x less than equal to 12 minus 4, so that negative 2x less than equal to 8. If we want to solve for the x, we need to divide for both sides with negative 2. For the inequalities, if we divide by negative number, the sign for the inequality will be changed. So we have here x greater and equal to negative 4. This is the answer for the right hand side. Now, how do we combine these two answers? So, we need to start by drawing a line number. What number should we write on our line number? Here we have negative 4 and 4 over 7. So negative 4 will be somewhere on the left and 4 over 7 will be somewhere on the right of our 0. So for the answer on our left hand side, we have x less than 4 over 7. We start with 4 over 7 with open circle since it is less than. So our arrow will be shift towards the left. So for our second answer, we have x greater and equal to negative 4. We start with negative 4 with dense circle because we have here greater and equal to, so it will shift towards the right. The final part, we can combine these two arrows by considering the end or the intersection parts of these two arrows. So we have here, we can see that it intersects in the region of negative 4 and 4 over 7. So we can write the answer like this. X is in between negative 4 close and less than 4 over 7 open in the type of solution set. Or we can write in the form of interval, which is, it will be x is in between negative 4 close and 4 over 7 open. Now, let's look at quadratic inequalities. What is quadratic inequalities? We know that the quadratic equation is in the form of ax squared plus bx plus c equal to 0. So, for the quadratic inequalities, we only need to change the sign to be in the form of greater, greater and equal to, or less than equal to. So there's only one method that we can use to solve the quadratic inequalities, which is we can use the graphical method to find out the solution for the questions. Now let's check out the examples that we have here. For example 5, find the solution for the following quadratic inequalities. We have here 2 times 2x minus 3 is greater than 3x times x minus 5. First step you need to do is, you need to expand the bracket that we have here. 2 times 2x minus 2 times 3 greater than 3x times x minus 3x times 5. So we have here 4x minus 6 greater than 3x squared minus 15x. Before you solve the quadratic inequalities, you need to bring all the terms that we have to be on the left hand side so that we have the positive quadratic like in this form. Ax squared plus bx plus c on the left hand side and 0 on our right hand side. So what will happen if you bring 3x squared minus 15x to be on the left hand side? Yes, it will be negative 3x squared plus 15x. We don't want that 3x squared to be negative. So to make sure that after we bring them to the left hand side, they will be the positive quadratic. So we need to divide all the terms that we have here with negative numbers so that we'll have the positive quadratic after we move all the terms. So we have here, which will be negative 4x plus 6 and negative 3x squared plus 15x. What will happen to our inequality sign here? Yes, it will change the sign to be less than. So we have here 3x squared minus 4x minus 15x plus 6 less than 0. You will have 3x squared minus 19x plus 6 less than 0 after you combine with these two terms that we have here. To solve the quadratic inequalities, you need to factorize the equation that we have on our left-hand side by using the calculator. So you have 3x minus 1 times with x minus 6. These are the crucial terms that you need to find before you solve our quadratic inequalities. The factors on our left-hand side and the zero on our right-hand side. We need them to be in the factors form for the left-hand side so that we can find the critical numbers. Critical numbers can be found by solving the factors that we have on our left-hand side equal to 0. So we have 3x minus 1 equal to 0 and x minus 6 equal to 0. So x equal to 1 over 3 and x equal to 6. These two critical numbers that we have here, we need to put them on our line number so that we can draw the quadratic graph. So first, we draw the line number and find the position that's suitable for us to put x. X, I will put here x equal to 1 over 3 and x equal to 6 on our right, so it will shown to be in ascending order. Remember that the quadratic graph will be in the form of it's either like this or like this based on our value of a. It will in this type of shape if our a is greater than 0 and this type for x less than 0. So in our case, we have here is 3x squared minus 19x plus 6, which is our a is greater than 0 for a equal to 3. So the shape of our quadratic graph will be like this, passing through x equal to 1 over 3 and x equal to 6. To write the answer, we need to identify the shaded region for our graph. In our case, we have the factors are less than 0. So we need to shade the region of under the graph. We can see here that the sign is only less than. So the sign for the 1 over 3 and for the 6 here is just open. So we write the answer, it is x in between 1 over 3 and 6 open. Now let's check out for another example that we have here. For the question B, we have here 6 minus 7x minus 3x squared less than 0. So to solve our quadratic inequalities, we need to make sure that it is in the form of ax squared plus bx plus c on our left hand side and 0 on our right hand side. So I need to make sure or rearrange that negative 3x squared to be in the front. So I'll have negative 3x squared minus 7x plus 6 less than 0. To make sure that I'll have the quadratic, positive quadratic on our left hand side, I need to divide all the terms that I have by the negative number. After we divide by negative number, the sign of our inequalities will be changed to be greater than. So we have 3x squared plus 7x minus 6 greater than 0. To solve our quadratic, we need to factorize our left hand side with the calculator. So we have x plus 3 times with 3x minus 2 greater than 0. After we have the factorized factors on our left and 0 on our right, so please mark this line that this is crucial for our final answer. So we can find the critical numbers by solving our factors that we have. X plus 3 equal to 0 and 3x minus 2 equal to 0. Our x equal to negative 3 and x equal to 2 over 3. Since we have the critical numbers now, we can draw the line number so that we can sketch the graph for our quadratic inequalities. In this case, we have x equal to negative 3 and x equal to 2 over 3 as our critical numbers. So I'll put x equal to negative 3 on the left and x equal to 2 over 3 on our right, since it must be in ascending order. So we need to check now for the factors. Here we have greater than 0. So for the a here is equal to 3, which is greater than 0. So our shape will be like this. I'll draw this graph now. Our graph will passes through the negative 3 and x equal to 2 over 3. Now I want to check for our shaded region. Our factors here is greater than 0. So our shaded region will be above the axis. How can we write the answer for this one? We can write in the form of our solution set. For the solution set, we need to draw in the curly bracket, we have x less than -3, or to combine our two answers here, x is greater than 2/3. Both of them will be open by following the original question. Or we can draw or write in our interval form. Interval form for the answer would be like this. It is from the -infinity up until -3 open, or by using the union notation starting from 2/3 until positive infinity. For the infinity, it always will be the open notation. That's all for our video for our quadratic inequalities. Next subtopic is rational inequalities. What is rational inequalities? It is the inequalities that involve fraction or the rational form so that we can solve to find the answer. The idea is we can write the inequality so that there is a single rational expression on the left side of the inequality and 0 on the right side of the inequality. Please remember that you do not cross multiply to find the answer. The method that we can use to solve rational inequalities are we can use table of sign or using the slant method. This is the form of the rational expression that we need to know so that we can solve the questions. Let's move to examples that we have here. For the example 6, you may refer to our lecture notes on page 7. Find the solution for the following inequalities. We have here x plus 4 over x minus 1 less than equal to 6. To solve the rational inequalities, we need to make sure that there is a single rational expression on the left side of the inequality and 0 on the right side of the inequality. From the question here, we can see that we have 6 on our right side. So we need to rearrange or bring the 6 to the left side, then we solve to get the 0 on our right side. So we have here x plus 4 over x minus 1 minus 6 less than equal to 0. To get the single term or the single expression of our fraction, we need to equate the denominator here by 6 over x minus 1. So we have here like this. And then, finally, after we solve the expression that we have here, we can end up with negative 5x plus 10 over x minus 1 less than equal to 0. From this here, we can see that we now have the single rational expression on our left side and now 0 on our right hand side. So we may now proceed by using the table of sign to solve the equation. Now I want to show you by using the method of using table of sign. Now, firstly, before we draw the table, we need to check for our critical numbers. Critical numbers we can find after you solve the factors that we have here. So we have first negative 5x plus 10 equal to 0, then x now is equal to 2. Another one is we solve the factors that we have on our denominator, which is x minus 1 equal to 0 and x equal to 1. Now we can draw the table by using the critical numbers that we have before, which is x equal to 2 and x equal to 1. For the first column, I want to fill in with the interval. The interval that we need to consider here is by the critical numbers that we have, which is x equal to 1 and x equal to 2. So that is our boundary to our tables. Now you need to make sure that which one is open or which one is closed. From the critical number here, we can see that x minus 1 is at the denominator. So for the x equal to 1, it must be open. And for the numerator here, we can see that the sign is less than equal. So for the numerator, it will be close. it will follow the sign order for our fractional expression here. So for the numerator, we have x is equal to 2. Hence, we can close at the 2. 1 will be open. From the beginning, it always will be from negative infinity, and at the end will be plus infinity. Now you can write the interval that we have here. It is, for this box, it is negative infinity up until 1, and 1 up until 2, 2 up until positive infinity. We have seen here that 2 is closed. So for the 2 critical, we can close for both sides. And 1 is open, so open for both sides. What about infinity? Infinity will always be open. Now for the second row, we need to fill in with the value of x. You can choose any value of x that we have from our interval. Let's say for the interval negative infinity up until 1, you can choose any number, but please remember that it is always be useful if you choose the number that is nearest to 1 in the interval. So I want to choose 0 for this one. For the 1 up until 2, we want to choose 1.5. You can choose any number, remember, as long as it is in the interval. Now, for the interval 2 up until positive infinity, I want to choose 3. Next is, you need to go back to our single rational expressions that we have here. We have the factors negative 5x plus 10 on our numerator and x minus 1 on our denominator. So please fill in both of the factors that we have here into our table. So we have here negative 5x plus 10. Another one is, we have x minus 1. Now, you just need to check on the sign. If we substitute the value of x that we choose from our interval before into our factors that we have. So if you substitute 0 into the first factor, negative 5x plus 10, you will get 10. So 10 is in the positive sign. Do the same thing for the 1.5. Substitute into negative 5x plus 10. You will get the positive sign. If you substitute the 3 into negative 5x plus 10, you will get negative. Same goes to our factors for the x minus 1. If you substitute 0, you will get negative. 1.5, you will get positive. And 3, you will get positive. Lastly, we need the row of our conclusion to get the answer. So for the conclusion, you just need to refer on our single expression of our fraction here. So we have negative 5x plus 10 over x minus 1. So for our table, it is for upper over lower to get the conclusion. Remember that we just need to only write the sign for our expression. So here we have positive over negative, you will have negative, and positive over positive, you will have positive, and negative over positive, you will have negative. To choose which region that we should choose to be our answer, you need to recheck from our expression that we have here. The expression here shows that it is less and equal to 0. Less and equal to 0 means it is negative number. So we need to choose the negative part or negative region to be our answer. From here, we can see that it is negative for the interval negative infinity up until 1 and negative for the interval 2 up until positive infinity. We have two separate intervals here. So to combine these two intervals, we need to use the sign of union as our answer. So our final answer will be negative infinity up until 1 union with 2 up until infinity. From now, I'm sure that you have the idea by using the table of sign to get the answer for the fractional inequalities. So let's check out another example that we have here. Say, for the example B, we have here 3 over x minus 3 less than equal to 2 over x plus 2. For the rational inequalities, please remember that we need to make sure that there is only a single rational expression on the left side of the inequality and 0 on the right side of the inequality, so that we can solve by using any method, which is either by using the table of sign or by using the slant method. Now for this example, I want to show you by using the slant method to solve the rational inequalities. First step you need to do is, from here we can see that we have the expression on our right side. So we need to move them to be on the left side. Now I want to move the right side of our fraction that we have here, which is 2 over x plus 2, to be on the left side. So we will have 0 on our right side. So we have here 3 over x minus 3 minus 2 over x plus 2 less than equal to 0. Now we have two expressions on our left side. To make sure that we have only single fraction or single expression, we need to equate the denominator that we have here. So we'll have 3 times x plus 2 minus 2 times x minus 3 over x minus 3 times with x plus 2. In this case, now we have x minus 3 times with x plus 2 on our denominator. You don't need to expand the bracket that we have here, since we want them to be in the factors form. You just need only to expand the bracket that we have on our numerator. So now we'll have x plus 12 over x minus 3 times with x plus 2 less than equal to 0. From this part, we can see that we now have the single expression on our left side and 0 on our right hand side. From here, after you identify the critical number, now we can use the slant method to solve this inequality. I want to find the critical number by solving the factors that we have on our expression here. So we have x plus 12 equal to 0. So critical number will be x equal to negative 12 on our numerator. For our denominator, we have x minus 3 and x plus 2. We need to solve them separately to get the critical numbers. So we have x minus 3 equal to 0 and x equal to 3. Another one is x plus 2 equal to 0, hence x equal to negative 2. Now I want to show you how we can use the slant method to find the answer. By using the slant method, firstly, you need to draw the line number. It is the line number for the value of x. Value of x that we have here by our critical numbers, we have negative 12, negative 2, and 3. You need to put them in the correct order. So we have negative 12 on our left side and negative 2 for the next and 3 on our right side. It must be in the ascending order. Next step is you need to identify which one is the closed critical or the open critical. I want to check for our critical here. For the x plus 12, it is on our numerator, and since our sign for our single expression here is less than equal to, it means here that it will be closed for x equal to negative 12. So we draw the close dot here. And for the denominator that we have, x equal to 3 and x equal to negative 2. Please remember that denominator will always be open. So it will open for the x equal to negative 2 and open for the 3. We use the sign of empty dot for the open interval. Next, we need to check what is the sign that we have for all the regions here. We need to check the region for the negative infinity up until negative 12 and for the region of 3 up until positive infinity. From here, you can use your calculator and insert the expression that we have here into your calculator. So we have the expression of x plus 12 over x minus 3 times with x plus 2. Next is, you need to choose any number which is suitable in this interval. for the interval negative infinity up until negative 12, I want to choose the negative 13. And for our negative 12 up until negative 2, let's say I want to choose negative 5. And for the negative 2 up until 3, I want to choose the number of 2. And for the 3 up until positive infinity, let's say I want to choose the number of 4. So now we can calculate each of this number into our expression from your calculator. So for negative 13, calculate for this expression, it will show you the negative sign. And for the negative 5, you calculate using the calculator for the expression, you will have positive. Do the same for the interval negative 2 up until 3, you will get negative and positive for this interval. Lastly, we want to choose which region should be our answer. So if we check from our single expression that we have here, it shows that less and equal to 0. It means that we want the negative region to be our answer. So the negative region that I have here is negative for the negative infinity up until negative 12 or negative 2 up until 3. So we can write the answer like this. X is correct for the x less and equal to negative 12 or x in between negative 2 up until 3. You can see that for the negative 2 and 3, it is open, and for the 3 open, it is only closed for the negative 12. That's all for our rational inequalities. Happy learning!